students. 1, 2, 3. Hello students, my name is Nariman Melim. I'm located in Baku. Here you can see my mobile and email. If you would like to get more SAT physics tests, two steps: subscribe to my channel and send a request by email to ernariman@hotmail.com. Today we will discuss practice test number 1 from the official SAT study guide subject test physics of March 2017. The test that follows is an actual previously administered SAT subject test in physics. Test basics. A number of questions, 75 multiple choice questions, timing 60 minutes, calculator, no any calculator. So no any calculator in SAT physics means that students should be able to do arithmetic and only simple formulas are needed. This is a good thing. In this video I will give simple solution based mainly on formulas. In the upper panel you will have question, in the lower panel solution. Let's start. Physics test number 1. So G you can take 10 meters per second squared for the acceleration of gravity at Earth's surface. Part A. A choice may be used once, more than once, or not at all in each set. Let's start. So question 1, 2. The figure above represents a track on which an object slides without friction. So without friction we will underline because this is important. The object is released from the top of the track in the position shown. Question: at which of the labeled point is the object's potential energy greater? So we have A, B, C, D, E. Formula for potential energy. Potential energy equals mgh. It means that potential energy is maximum when height is maximum. So maximum height we have at point A. So we choose A. Question 2. At which of the labeled point is object kinetic energy greatest? Kinetic energy, mechanical energy, consists of potential energy and kinetic energy. It is conserved and is constant because there is no friction. Kinetic energy maximum when potential energy is minimum. It means that height is minimum. So we choose minimum height is at B. Question 3, 6. Let's open question. A person throws a ball with an initial speed v0 from the deck of a house in any one of the 4 initial directions shown in the diagram above. In each case, the ball is released at height h, capital H, above the ground. Air resistance is negligible. So let's look to the question itself. In which case does the ball travel the greatest horizontal distance before hitting the ground? So horizontal distance will be traveled at constant speed. So formula for horizontal distance traveled, x will be a horizontal component of speed multiplied by time. So for cases B and C, horizontal component is 0. So distance traveled will be 0. Now we should compare A and D. Horizontal component of velocity for A is greater than for B. V0 versus V0, for example, sine theta. So we have some component V0, for example, sine theta. if this is angle theta, right? Time. What about time? So A is falling from 0 meters per second, and in D we have some component V0 cosine theta. So we have some component. So in both cases we have acceleration 10 meters per second squared, but in A object move at higher speed, initial speed. So time will be taken to reach the ground greater in A than in D. As a result, the distance is horizontal. So time greater, so we choose A. So speed, horizontal component is greater and time is greater. In which case does the ball have the greater speed when it hits the ground? This is a tricky question. So why? Because in all cases we have the same mechanical energy, which consists of potential energy and kinetic energy. So direction doesn't matter, so kinetic energy is scalar, so both of them have the same total energy. When they hit the ground, all energy becomes kinetic energy, so they all have the same final, so they have the same final kinetic energy, and as a result they have the same final velocity. So we choose choice E, which means that they have the same velocities. In question 5, in which case does the ball have the greatest acceleration just before it hits the ground? In all cases, the same constant acceleration of 10 meters per second squared. So this is choice E. In which case the ball in the air for the longest time? Let's compare. So in B, object moves up, reaches highest point with 0 velocity, and from this highest point falls. So the height from which B falls is the greater among our objects. And so in B goes up and falls from the higher positions than A. Formula S equals ut plus gt squared over 2 turns into height equals gt squared over 2. So the greater the height, the greater the time of fall. So B has height greater than h and hence greater time. So it also goes up. So it takes more time. In C and D, the both cover distance h at higher speed than in B. Smallest distance and higher speed, so less time. So we can compare A and B, and A has greater than C and D, but B has greater than A, so greater time is for B. This was question 6. Now we go to question 7. Question 7.8 refer to the following properties of light waves: frequency, wavelength, speed. In a vacuum, all colors of light have the same value for which of the properties? Of course it is speed, so we choose all colors the same, only speed, so we choose B. When light passes from air into glass, which of the properties changes? Frequency doesn't change. In more dense media, speed decreases. As wave equation gives us formula V equals F lambda, it means that lambda equals V over F. So V decreases, lambda also decreases, so we choose D. So wavelength is changing and speed is changing. Now question 9-10. A block, okay, so let's look to the question. A block on a frictionless tabletop is attached to a horizontal spring that is fixed to a wall as shown above. The block is pulled to the right. Choose answers to the following questions from the set of graphs below. So which graph represents the magnitude of the linear restoring force as a function of the block's displacement from its equilibrium position? So here we see restoring force. Actually, what we see here is, this is standard model, simple harmonic motion. So restoring force F equals minus kx. Or because we have here spring, we can say that force equals minus kx. In both cases, force is directly proportional to displacement, and in this case graph should be straight line through origin. Let's see whether we have this. Yes, we have B, straight line through origin. We should take choice B. Which graph represents the elastic potential energy stored in the spring as a function of the block displacement from equilibrium? Equation for elastic potential energy equals half kx squared, where x is displacement. So graph should be parabola. Let's look for parabola. Parabola is E, so we choose E. We choose E. Question 11-12. A particle moves along the x-axis and is acted on by a net force directed along the line of motion. Possible graphs of velocity Vx as a function of time t are shown below. All graphs are drawn to the same scale. Question 11. Which graph is not possible for a force that is constant in magnitude and direction? Constant force along the line of motion means that acceleration is also constant. As acceleration is equal to gradient, it should be also constant. And why I talk about gradient? Because it is gradient of velocity time graph. So we should have constant, not constant, acceleration. Let's see. So positive constant, negative constant, positive constant. But here it's not constant because it is positive and then negative. So it's not possible. So we choose E. Choice E. 12. Which graph describes a situation in which velocity of the particle changes direction between time t0 and t1? Changes direction means change sign of velocity. Let us see where we change sign. So here all the time positive, all the time positive, all the time positive, all the time positive, but here it is positive and then negative and then positive. So change sign, change direction. The reason is that the force is in the opposite direction. Question 13-15. 13-15. Let's open question. Right. The following diagrams each represent an isolated charge plus q at the center of a circle shown In each case, a test charge plus Q is moved from rest at X to rest at Y by external force along the path. The net work done by external force is maximum in which of these cases? By definition, change of potential equals work done by charge. So work done equals charge by change of potential. For point charge, potential is inversely proportional to distance. So in 2 and 3, because we have a circle, so X and Y are the same distance, so potential at Y and X are the same, so change of potential is 0, work done will be also 0. The same story here. So X and Y are at the same distance because they are on the circle, so change of potential is 0, work done is 0. When we move charge from X to Y, because distance at Y is less, potential here is greater. So change of potential is not 0, so we're doing work, so the greatest work is done here. No net work is done by external force in which of these cases. So as we discussed, no work is done in 2 and 3. So from question 13, it is 2 and 3. The electric potential at Y is higher than at X in which of these cases? Because in cases 2 and 3 potentials are the same, and here point is closer, so potential is greater at Y than at X, so we choose 1 very easily. 16. The statement below describes experimental observation of processes involving electrons. An electric current, so let's discuss one by one. Electric current passes through a gas and a characteristic spectrum is observed. Line emission spectra of gases when current passes through. Electron diffraction on atomic as electrons are scattered from the surface of a metal and diffraction pattern is observed. So electron diffraction on atom structure proves wave property of otherwise particle electron. Electrons are dislodged from a metal surface that has been struck by photons, and the energy of the electrons is measured. Photoelectric effect. Light behaves as stream of particles, photons. Electrons absorb photon energy and escape. Evidence. Okay. Evidence for which let's skip this. Evidence for the particle nature of light is provided by which of the observation? As I discussed, particle nature of light is provided by 3. So light is absorbed as particle and can produce photo effect described in 3. Evidence that an electron needs a minimum energy to leave a surface is provided by which of the observation? Again, photo effect, it is 3. Questions 18-19 refer to the following types of images that may be formed when an object is placed in front of lens or mirror. So here we have real larger, real smaller, virtual, and let's look at the question. For which of these types of images can be formed by a convex mirror shown above? So convex mirror can produce only virtual image, so we choose 3. Which of this type of images can be formed by the converging lens shown above? So this is above. So for converging lens we can have larger, real, small, real, and virtual. Questions 20-21. Question 20. Standing waves are produced on the strings of a guitar. The following represent comparison of the fundamental frequency and the fundamental wavelengths of the waves when change is made. So frequency and wavelengths either lower or stay the same or shorter. Higher or shorter, longer or... okay, right. The guitarist first plug a thin string and then a thick string, where both strings are the same length and under the same tension. So wavelength doesn't change because it is associated with the length of the string. Speed equals tension and mass per length. Thicker, so tension doesn't change, but thicker means more mass per length, so mu increases, velocity decreases, frequency equals velocity over lambda, so frequency also decreases or becomes lower. So we have wavelength doesn't change and frequency lower. Frequency lower stays the same, so it is B. Right. Now the guitarist plugs a string with then tightens it and plugs again. In this case, the same lambda doesn't change, so speed will be decreased because speed increase, tension increase, speed increases, frequency then increases. So in this case, we have higher frequency and the same wavelength, so E. Question 22. Right. Which of the following is the correct unit for the coefficient of friction, mu? So first of all, formula for friction force equals mu times normal reaction. Rewriting for mu, we get force over force, no unit. So no unit is E. 23. A rocket-powered sled is accelerating along a straight level track with constant acceleration of magnitude 20 meters per second squared. By how much will the speed of sled change in 3 seconds? So acceleration equals change of speed by time. Rewriting for change of speed, we'll have acceleration by time. We put numbers, 23, we get 60, so we choose D. The block shown above is pulled over a rough horizontal surface by the tension force T in the string. The velocity of the block does not change, and therefore it may be correctly inferred that... and let us see what we have. The inertial mass of the block is infinite. Nonsense. The inertial mass of the block is zero. Nonsense. The force due to the friction and the tension are equal in magnitude. We have here velocity does not change, so forces are balanced, and choice C is very well fits here. The block will continue to move at a constant velocity if T is reduced to zero. Nonsense. This constant velocity condition can be maintained by a tension of any desired value. Nonsense. So we choose balanced forces. First Newton's law, then we have constant velocity. 25. Question 25. A 2 kg box is placed on a scale in an elevator. When the elevator is not moving, the reading on the scale is 20 Newton. When the elevator is accelerating upwards at 2 meters per second, the reading on the scale will be most nearly. So we have box in a lift. Here I have drawn a picture of a person. So we have second Newton's law, resultant force equals ma. Because it accelerates upwards, tension or reaction of support, normal reaction will be greater than mg. So normal reaction minus mg equals ma. Rewriting this formula for normal reaction, we get mg plus ma. This is the force that the floor exerts on the box and box exerts on the floor. This is what we read on the scale. So mg plus ma, 20, it is weight, normal weight, and 2 times 2, it is ma. So 24, we choose 24. The observation of diffraction pattern produced when monochromatic light is incident on narrow slits provides evidence for which of the following? Observing diffraction. So diffraction is wave property. So where we have wave property, wave nature of light. So it is B. 27. The phenomenon responsible for the separation of colors in the formation of rainbow is also the cause of which of the following? Here the main word is separation. Separation of color. Separation of colors we have only in E. Spectrum formed by a glass prism. 28. A small cork moves under the influence of a water wave whose shape at a particular time is shown in the graph above. If the wave has a speed of 2 meters per second, how long does it take for the cork to make a complete oscillation? So we have wave. Each particle of the wave is making oscillations, and cork will show us these oscillations. So actually we need to find period. To find period we need frequency. To find frequency we need speed, which is given, and wavelength. So wavelengths we can find because we have here 1, 2, 3, 4, 5 complete waves covering 25 meters. It means that one wave will be 25 by 5 meters. So period, period should be found, wavelength we found. From wave equation we can find frequency, f equals v over lambda. Would put here speed 2 and wavelength 5, we get 0.4. We divide 1 by 0.4 using formula period equals 1 over frequency. And we get 2.5. So this was question 28. 29. An astronaut is on a planet whose mass is twice the mass of Earth and whose diameter is the same as Earth's diameter. The astronaut's weight on this planet is. Weight is gravitational attraction. So in case 2 we have all the same except mass of the planet is 2 times more. If we take 2 out of bracket, we get the same force multiplied by 2. So force will be 2 times greater. So twice what it is on Earth. 30. A toy train undergoes 3 periods of constant speed as shown in the graph above. 6 seconds moving at 2 meters per second, 4 seconds standing still, and 10 seconds moving at 3 meters per second. The average speed of the train for this 20 seconds is most nearly. So average speed formula, total distance divided by total time. Distance is area under the graph. So it should be total area under the graph. Let us choose this. So it is this area, and if we and this area. So we should, this is rectangle, we should calculate area of rectangles. One rectangle is 2 by 6, another rectangle is 10 by 3, 30 and 12. So we get 42 meters traveled. Total time is from 0 to 20 seconds. Regardless of the fact that it was not moving, we take total time. So this is the trick here. So we get 2.1, we got the answer. Next question, 31. 33. So we have graph velocity Vx versus time of an object moving along the x-axis is graphed above. The object is instantaneously at rest for each of the points. So at rest means velocity is 0. So it is point B and it is point E. At B at E, so we choose D. The magnitude of the object's acceleration is maximum in the region between which of the two points. So slope equals acceleration. The smallest acceleration or slope is 0 between C and D, because here we have non-zero and here we have non-zero. The smallest is at C and D. 33. At which point is the object's greatest distance from its position at t equals 0? So displacement is area under the graph, but displacement is vector, so it can be positive and negative. So at B, it traveled the distance equal to the area. Half 2v by 2t give us 2vt with minus. And of course at point A it traveled, so it moved to the left, for example, 2vt. But at A it moved to the left less, so B is our king at the moment. Then what happens next? It starts returning back. So distance decreases. Returning back. Let us see how much it returns. So from B to C, it returned half Vt. It is area under the triangle. Between B and D, it traveled return additional Vt. So it is 1.5 Vt. And from B to E, so additional dE, so return back. So moving away, maximum 2 Vt, and then returning, and finally returning back. So greatest distance will be B. Now question 34. An object of mass m is initially at temperature T0. An amount of heat Q is absorbed by the object, raising its temperature to Tf. What is the specific heat of the object? So formula looks like this. Specific heat definition is energy by mass by change of temperature. Only thing we do, we change of temperature right as Tf minus T0. And this is answer C. 35, 37. heat engine is represented in the figure below. During each cycle, the engine absorbs 600 joules of thermal energy from the heat source, and let me open more. And exhausts 500 joules of thermal energy to the heat sink. So we have here hot object that gives heat and cold object that takes the heat. Here we have temperatures, but in the text we have energies. How much work is done by engine during each cycle? So useful energy equals input minus wasted. Input energy is 600 joules and wasted or given to the heatsink is 500. So 100 joule is appear to be useful energy. If the engine operates at 20 cycles per second and does x joules of work during each cycle, which of the following is an expression for the power generated by the engine? So power equals total work by time. During 1 second we have 20 cycles multiplied by x give us 20 times x joules of energy divided by 1, 20x. So expression 20x works for us. 37. If the temperature of the heat source and heat sinks are 360 and 270 as shown on the picture, respectively, what is the theoretical ideal maximum efficiency of the engine? So in this case we use formula for efficiency using temperatures, hot minus cold divided by hot, and we get multiply by 100, we get 25. Question 38 to 39. The figure above depicts a thick glass mark, initially at room temperature, in which a sensitive liquid in glass thermometer has been placed. A student pours very hot water into the mark. Question 38. The student carefully observes the reading of the thermometer and sees that it initially drops and then gradually rises. The student's observation can be explained by which of the following? First, heated is the glass. It expands as a result level of liquid drops, and later on liquid is heated and expands and level rises. So we choose answer D. The thermometer glass expands before liquid inside it expands. Very good. Soon after the hot water is poured into the glass mass, the mud cracks open. This is most likely due to which of the following? Cracking is due to the different expansion. Of course, first inner part is heated and expand more than outer part, so we have cracking. So let's see which choices we have in 39. So we choose B. The inner wall of the mug expands before the outer wall does. Question 40. Two samples of an element are prepared, each containing a different isotope of that element. Which of the following properties of individual neutral atom is not the same for both samples? Isotope have the same number of protons but different number of neutrons, hence mass number. So atomic mass is different. Atomic number is the same because the number of protons. Number of protons is the same. Number of valence electrons equals to number of protons. The same. Total number of electrons is the same. The actual valence electrons has nothing to do here. Not the same for sure atomic mass. 41. A spaceship is traveling towards the Earth at speeds of 2 times 10 to the 8 meters per second when it fires a laser pulse directly at the Earth. What will observers on Earth measure the speed of the laser pulse to be? So this is a tricky question, very popular question and very tricky. One of the two postulates of special theory of relativity. In all frames of reference, light in vacuum has speed of 310 to the 8 meters per second. So you should memorize this number. This is very important number and you should memorize it. So answer is D. According to present experimental evidence, which of the following is true of protons and electrons? Their charges are of the same sign. Wrong. They have the same mass. No, mass of electrons is 2000 times less. They are not known to decay. This is under question mark. I don't know. They are both made of quarks. Wrong. Protons are made of 3 quarks, but electrons have no structure. They are about the same size. No, size of electron is much less. So out of the by method of elimination, we eliminate A, B, D, and E, and we take C. So it looks that they are not known to decay. Theoretically, a proton can decay, but this was not observed practically. Correct statement about atomic nuclei include which of the following? Two nuclei with the same charge contain the same number of protons, right? Nuclei are positively charged, right? The nuclei contain a small fraction of mass, wrong. So nuclei consist of protons and neutrons. Protons positively charged, neutrons no charge, electrons negatively charged. Mass of electron is 1/2000th of mass of neutron and proton. This is why the last one is, so we have true, wrong. So this is C. 1 and 2 is only correct. Equal charges are placed on two identical conducting balls that are suspended from a common point by a very long string as shown above. When they reach equilibrium, the balls are at angle theta from the vertical. A third identical but uncharged ball is attached to the charged ball on the left and then removed. Which of the following shows the possible position of the balls when they again reach equilibrium? Touching by another ball will discharge partly the left ball. Force of repulsion, so part of the charge of this ball it will lose. The force of repulsion will decrease because it depends on both charges. But according to Newton's law, the forces will be still the same. Less forces of repulsion, but will be the same. So as a result, just angle will be less, but angle will be the same. So let's see whether we have such situation. No change, wrong. Different forces acting, wrong. So the same forces, but smaller. So D is correct. Next question. Two charged particles in a uniform electric field between two large parallel plates are at the positions shown above when they are simultaneously released from rest. If the two particles reach the negative plate at the same time, one can definitely conclude that they have the same, and we have charge, mass, what else? Charge, mass, charge and mass, product of charge and mass, ratio of charge and mass. So let us split again. And we need question 45. Right. Okay. So here we have constant uniform electric field, constant force on constant mass, constant acceleration. So they both move at constant acceleration. This is the formula. They start from rest, so we choose this formula. S equals ut plus half at squared. U equals 0, so formula simplifies to S equals half at squared. As we have the same distance traveled, the same time, it means that they have the same acceleration. On the other hand, acceleration equals force over mass. Force equals charge by field strength. Substituting this expression for force, we get ratio of charge by mass multiplied by field strength. So they have the same, this ratio, charge by mass, and we have such answer, ratio of charge to mass. The force on a straight current carrying wire in a magnetic field is perpendicular to the wire, depends on which of the following. So this is the formula for the force on a straight current carrying wire. So we have here angle is perpendicular, so angle is 90 degrees, so sine is 1. ILB, so current, length, and field strength. Strength of magnetic field, yes. Current, yes. Length, yes. So all three are important. So all three are important is E. 47. A number of small magnetic compasses on a wood tabletop are oriented as shown above. These compasses are most likely situated. So we can actually see here a circle. One circle, another circle. Such magnetic field is characteristic of magnetic field around straight wire. So let's see. Around a current carrying wire passing perpendicular through the hole in the table at point P. So it is choice A. Next. By the way, to find direction of magnetic field you use right hand grip rule shown here, but they don't require this. So we go to next question. Right. A bit more space. Right. Okay. A positively charged particle moves to the left through a magnetic field B that is directed out of page, as shown above. What is the direction of the force exerted on the particle by the magnetic field? For positive charge, we think that it moved to the left, so conventional current is to the left. We use Fleming's left-hand rule. So first finger along field, second, so how to do it? So first finger field, second finger conventional current, and thrust is shown by most. So fold all fingers, open first finger, and point it towards you out of page, because magnetic field is this way. Then turn your fingers turn your hand, let's say open second finger and turn your hand clockwise until it shows you to the left. As a result, the thumb will show you up. So let me show. So your first finger points this way first. Second finger point you this way, and the thumb shows direction of the thrust up. So choice is towards the top of the page. Next question is about transformer. Which of the following statement is true of a transformer? Let me introduce transformer to you. A simple transformer, this is a simple transformer, consists of two main parts, two coils, main part coils, primary coil and secondary coil. Primary coil is connected to AC voltage, and these two coils have iron core between them to increase linkage between magnetic linkage between these coils. How does transformer work? Alternating current in primary coil generates changing magnetic field in the iron core. This induces EMF and current in the secondary core. So alternating current in the primary core generates changing magnetic field that induce alternating current and EMF in the secondary coil. Taking this into account, let us see which choices we have. It uses an iron core to reduce the magnetic flux linkage between the primary and secondary, vice versa. The voltage induced in the secondary coil is due to the changing magnetic flux set up by the changing current. It looks okay. It is a DC device. Wrong. It is AC device. It is an AC device that is based on capacitor. No capacitor. It is an electric motor run backwards. No, electric motor run backwards is generated. So we choose answer B. Question 50. A bar of conducting metal moves with speed v in uniform magnetic field B. In which of the following situations will a difference in electrical potential exist between end 1 and 2 on the bar? So, all three directions should be perpendicular. Direction of wire, direction of field, and velocity. And if we look through the choices, here we straight have this situation. So 90 degrees, 90 degrees, and 90 degrees. Three-dimensional picture. Here, velocity and wire are parallel. Here, velocity and wire are parallel. Here, velocity is parallel to magnetic field. Here, Y is parallel to magnetic field. So only this choice A will have EMF induced. 50. Why does our calendar usually include a leap year every 4 years? One cycle of the this answers. One cycle of rotation around the sun is taken as a year. It takes 365 and about a quarter days. This is why every 4 years we have leap additional year which almost covers missed quarters. Which choices we have? The moon's orbit around the moon has nothing to do. The period of Earth's orbit is not an integer multiple of the period. So it's not 365, it's not 366, it is in between. So we choose B. 52. In some designs for high-speed magnetically levitated trains, there are superconducting electromagnets in the bottom of each car. This design is chosen because when compared to conventional electromagnets, superconductivity, almost zero resistance, and heat losses when current flows. Power losses due to heating effect of current, so resistance zero, power losses will be zero. And in the choices we have choice A, use less electrical power. '53. The wavelength of a wave is plotted versus its period on the graph above. Which of the following graph best represents the wavelength versus frequency? Wavelength here is directly proportional to period, but period is 1 over f. It means that wavelength is inversely proportional to period, and inverse proportion we have in this graph. This is a graph for inverse proportion. For example, here wavelength decreases but frequency increases. Here they both increase. Here frequency increase, wavelength decrease, and vice versa. Here they both increase. Here wavelength is constant, so we choose this case C. The speed of light in a glass prism varies with the, remember, frequency. Depends on frequency. Light of different frequency have different speed. 55. The bottom half of a converging lens is covered so that light from an object can only pass through the top half of the lens. What image will appear on the screen on the opposite side of the lens? To find image, we use standard rays. Via optical center. Okay, let me show. Right. So one ray is going through optical center. It doesn't change direction. Another ray is parallel to optical axis. It goes through focal length. They intersect here, and here is the position of the image. In reality, the object sends billions of rays in all parts of the lens. So this means that if you cover any part, still you will have the same image. It will be not so bright, dimmer, but at the same position, the same image. And I think we have such choice. The entire object is the best answer. Yes, we'll see entire object. 56. A wave has a frequency 60 Hz. Which other property of the wave can be determined from this information alone? So wavelength and frequency are linked by this equation, so we can find period. Right. In experiment, question 57-58, in experiment, a student has connected 3 initially uncharged capacitors and a battery, as shown in the figure above. What is the equivalent capacitance of the circuit between A and B? So if we look, So first of all, let's find capacitance of this part. Two capacitors in series. So formula is the same, is you use formula for inverse. So you add inverses and you get inverse as a result. It is 1 over 8 plus 1 over 8, 1 over 4. Inverse is, so C is reciprocal. So we get equivalent capacitance of these two capacitors connected in series is 4. 4 and 4 in parallel, we just add, we get 8. So the formulas are the same, but vice versa, like for resistors. For series, inverse formula, for parallel, adding formula. What are the voltages across the capacitors after the equilibrium has been reached? So C1 is in parallel with cell, so voltage should be 6 volts to stop the current flowing. This voltage is between A and B. So this voltage is shared by C2 and C3. And because they are identical, they share it equally. So 3 volt here and 3 volt here. So we get C1 6 volt, C2 3 volt, and C3 3 volt. $59.60. To confirm Ohm's law, an experiment is performed with a battery, ammeter, voltmeter, fixed value resistor, and variable resistor. Which of the following circuits would allow you to take appropriate measurements to verify Ohm's law? Ohm's law says that for resistor at constant temperature, current and potential difference are directly proportional. So it should be one element. Let's say here it is fixed element, so it should be a fixed resistor. Voltage is measured across fixed resistor, so we choose this, and current through this resistor. So A works. So we should measure, so we should take fixed resistor for study, measure voltage across fixed resistor and current through fixed resistor. Here current is wrongly measured. Here not voltage is wrongly measured. It's not of interest. Here everything is wrong. Here we cannot here voltage is not measured across our element. 60. If R is resistance, V is voltage, and I is current, which of the following shows the relationship between the graphed quantities that is consistent with Ohm's law? In each case, assume the said quantity is held constant. Ohm's law: at constant temperature, current in a resistor is directly proportional to potential difference. It means that resistance is constant, and graph of current versus potential difference is straight line passing through origin. Let us see. So I think this is the best case. So straight line probably passing through origin. Not straight line, not straight line, not straight line. Here resistance should be constant regardless. Actually it has nothing to do with Ohm's law because there should be no resistance. 61. To determine the power dissipated by resistor, student obtains the following data: potential difference across resistor 10 volt plus minus 5%, current through resistor 2 amperes plus minus 25%. If the power is expressed as 20 watts plus minus x, x is most nearly. So this is the information given. V, I, and P. So power, formula for power is current multiplied by voltage. If we have multiplication to find, we deal with percentage differences, percentage uncertainty. So for example, this is general formula. So Z equals Ka BC. K is constant. Percentage uncertainty in Z will be equal to sum of percentage uncertainty. So in our case, the result is power. So percentage uncertainty in power equals sum of percentage uncertainties of here products, terms of the product. So we add and we get 30%. So we choose 30. 62. A steel spring with no zero mass has zero elastic potential energy with no forces exerted on it. A mass m is attached to one end of the spring and allowed to oscillate on horizontal frictionless tabletop. True statement about the spring includes which of the following? When the spring is compressed, it will have elastic potential energy greater than zero. Yes, elastic potential energy formula is half kx squared. X can be compression or extension, doesn't matter. So more than zero, true. When the spring is stretched, it will have elastic potential energy greater than zero. Also true because we use the same formula. The spring will always have zero kinetic energy. Spring stops for a while on the ends. In other moments, it moves forward or backward. So elastic potential energy change into kinetic energy. So kinetic energy is more equal to zero. So this is wrong. So we choose choice D. 1 and 2 is correct. Uh, 63-64. A foam ball is dropped from a tall tower. Assume that there is no wind, but that E resistance is directly proportional to the ball's speed. Which of the following is true about the ball's motion for a short time after it is released? Its potential energy remains constant. Potential energy equals mgh, so as object falls, it decreases, so it changes. Its speed decreases. All the time, it speeds up, mostly speeds up, at some time stops changing, but not decreases. Its acceleration decreases. Yes, acceleration decreases, and they ask about short time after it is released. Right, so speed for sure speeds up. Acceleration decreases as acceleration equals resultant force over mass, and resultant force is mg minus air resistance. Air resistance increases with speed, so resultant force decreases and acceleration decreases. So this is C is true. Its acceleration is constant but not zero. Wrong. CC. Its acceleration is zero. Wrong. CC. Okay, 65. 64. 65. Which of the following describes the conditions under which the total momentum of a system of particles is conserved? Principle of conservation of momentum states that if no external force acts on a system, the total momentum of the system remains constant, is conserved. So only whenever energy, nothing to do with energy, only whenever no external force acts on the system. True. So we choose B. 66. What is the centripetal force on an object of mass 4 kg traveling in a circular path with a radius of 20 meters at the speed of 2 meters? So here we just use formula mv squared, so force equals mv squared over r. So we substitute numbers and we get one of the answers, D. In an electron microscope, the beam of electrons is focused. The strongest force acting on moving electrons is magnetic force, so it is magnetic fields. Question 68-69. A person stands on a sled on a frozen lake. The friction between the sled and the ice is negligible. Initially, the person and the sled are motionless. The person then walks on the sled toward a dock as shown above. While the person is walking on the sled, how do the person and the sled each move with respect to the dock? Person, so 68. Person moves forward. So these are solution. Person moves forward, pushing sled backward, according to the third Newton's law. So this is why we choose towards the deck, away from the deck. So it is B. On the other side, we can talk about also another version, center of mass. Center of mass should stay constant because there is no forces acting. So object move forward, sled should move backward to keep the center of mass at rest. '69. Before reaching the end of the sled, the person stopped walking. Which of the following describes the velocity of person and the sled with respect to the dock after the person has stopped walking? Here I used conservation of momentum. Before, the momentum was 0. After, it should also stay 0. So, person doesn't move. It means that dock sled also should not move, and total momentum will be 0. So 0, 0, A. 70. So here at 0.1, 0.2 kilograms disk sliding at 8 meters per second on tables negligible resistance as shown. Above strikes a 1 kilogram disk sliding at 2 meters per second in the same direction. After the collision, the 0.2 kilograms slides backwards at 2 meters per second. What is the speed of 1 kilogram disk after the collision? I have drawn picture here. Let's choose the position direction to the right, positive. Then we have here plus 2 meters per 8 meters per second, plus 2 meters per second. Here we have minus 2 meters per second and z unknown. So conservation of momentum. Momentum before equals momentum after. So then m1u1 plus m2u2 equals m1v1 plus m2v2. U is this velocities before, v are velocities after. 1, 2, 1 object, second object. Substituting values. By the way, here 0.2 kilogram by 8 meters per second. So I don't know why mistake here. We have 8. 1.6. Then it is correct. 1.6. Here right, and as a result we get z equals 4. So if you substitute everything correctly, get, yeah, 2 and 2, so 2 and 2, 4, so it is 4, right. That was 70, we go to 71. The instance shown in the following diagrams, an object that is moving initially to the right with velocity v is acted upon by a net force in which of these cases is kinetic energy of the object not changing. Here object speed up, here object decelerate, here partly so speed up because we have some component along the direction. Here speed up. Only here when angle is 90 degrees there is no change in velocity. This is one approach. Another approach says that change of kinetic energy equals work done. Work done equals force times displacement. And this work is 0 when angle is 90 degrees. When force is perpendicular to displacement, it is also perpendicular to velocity. No work is done and no change of energy. Perpendicular force we have only in E, so we choose E. Right, next question. 72. The figure above shows the trajectory of a saucer ball kicked by a player. The speed with which the ball leaves the player's foot is v0. The initial angle between the tangent to the trajectory and the horizontal is theta 0, which can be any angle between 0 and 90. If air resistance is negligible, which of the following is certain to increase both the distance d of the kick and the time of the flight in the air? So let's look to the diagrams. So here we see that actually we should move it a bit down and look this way. Right, so component, so V0 can be resolved into horizontal component V0 cosine and vertical component V0 sine theta. So going up, vertical component of the velocity at start V equals u plus at. So in the end v equals 0, at the top v equals 0, and initial velocity v0 sine theta 0 minus gt because we choose positive direction up but g is down. So time of flight up will be v0g sine theta 0. But flight consists of two parts, up and down. The times will be equal, so we have time of flight is 2 times v0g sine theta. Distance traveled horizontally will be horizontal component multiplied by time of flight. So substituting the values v0 cosine theta and time of flight 2v0 sine theta 0, we have cosine and sine theta. So product of this function has 0 at angle 0 and 0 at angle 90 degrees. Maximum is when angle is 45 degrees. So let us see. Increasing both v0 and theta 0 doesn't work because theta 0 can increase or decrease distance traveled. Increasing v0 and decreasing. Increasing v0 and keeping T0 unchanged. I think this is the best, so answer C is the best. 73. Particles enter a slit in a rotating drum of known diameter and rotating speed as shown above. They strike the darkened region of the target inside the drum, which is at known angle from the slit. With no additional data, this experiment can be used to determine which of the following properties of the particle. So we have known diameter, speed, angle. So let's summarize what we know. So this is a picture. So we have this, let's call it distance d. So distance, we know this distance. We know angular speed, we know angle of rotation. So speed will be distance divided by time, speed of the particle. So it travels distance t by time t. The question is how to find time t. Time we can find from angular speed. Angular speed is angle rotated by time. Time will be angle by angular speed. So we can find speed. Do we have such choice? Speed of particles. Yes, we can find speed of particle, B. 74. Two planets, that are far apart have the same mass, but planet Y has a radius 3 times that of planet as shown above. If A is magnitude of acceleration due to gravity on surface planet X, what is the magnitude of the acceleration of gravity on surface planet Y? So force of attraction is F, given by this formula. We divide by mass of one object, we get this formula. Case Y, all the same except radius is 3 times. So we take 3 out of bracket and we get 1/9 of the previous value. So we have such choice, 1/9. Yes, A over 9. And finally, last question. A car is being pushed up a hill and moves with constant velocity. What is the direction of the net force acting on the car? Constant velocity means forces are balanced, net force is 0. This is end of the test. Thank you for your attention. We can look to the equations that we used. So we used here about 40 equations. So potential energy, mechanical energy, total mechanical energy, kinetic energy, constant motion under gravity, wave equation, restoring force, Hooke's law, elastic potential energy, second Newton's law, potential difference formula, potential of a point charge, speed of in a string. Then we have friction formula, acceleration formula, second Newton's law, link between period and frequency, gravitational attraction force, average speed force, finding distance from area under the graph, formula for area under triangle, formula for heat when temperature changes, useful work done in heat engines. Power is work by time, efficiency using temperatures, force, magnetic force on a wire with current, heat losses in the wire with current. Then we have total resistance for capacitors connected in series, total resistance for capacitors connected in parallel. power in a current, one of the formulas. Power equals current multiplied by voltage. Finding percentage uncertainty for value that is calculated from multiplication. I don't know what is this formula. Right, so this is centripetal force. This is conservation of momentum. This is another form of conservation of momentum. Work done equals energy change. Work done equals force time displacement time cosine of angle between these two vectors. Velocity equals u plus at. Speed equals distance by time. And angular speed equals angle divided by time. Thank you very much for your attention. If you need more solid physics tests, subscribe to my channel and send requests.